4, 5, and 6. Okay, so we can move this to this place, and we are not, and then we're not going, we're not going to count this because it's easier if we find the area of this triangle. Okay, now we can take this and we are going to count this instead of that one. And this, we are going to move to this place. Okay. So we are going to count, for example, maybe, okay. If we put this from here to here, we move this from here to here. We are going to count this. Okay. We're going to count this part. Okay, again. We are going to count all this. Yeah. Here we have 36.
Yeah.
Okay. And we can count. Here we have 1, 2, 3, 4, and this is 5. We have here 5 and here another 5 in this part of the figure. Okay.
Okay.
We will have this as 1. And what is the area of this one?
It's 2.
2. Okay. And the area of this triangle will be 3.
Yeah.
Here we have 1, 2, 3, another 3. Here we have 1, 2, 3, 4, 5, 6. And the area of this triangle will be 1 times 6, 1 times 6 divided by 2. We will have 3 here. So 36, this, plus 10, plus 4, 3, 6, 12, 14. We will have 40 and 10, 50 and 14. We will get 64. Do you understand this idea?
Yes.
Okay. So the answer will be 64. Now problem number 2. ¿Sí entiendes el problema 2? Do you understand the problem number 2?
Yeah.
Okay.
30.
Why? Can you explain?
If each student donated one or two books, then um not everyone could donate one book. 5 people need to donate 2 books, and the remaining 30 donated 1 book.
Okay. Let's see. You say that, how many? ¿Cuántos dijiste que eran?
13.
30. Okay. We have uh 30 students. Okay. And from 5 classes in one school decided to join to donate a book initiative and brought a total of 40 books. If 30 students donate everyone one book,
We have 30 books donated.
but we need 40. So it cannot be 30.
Um,
Yes.
25 students donated 1 book.
Okay, 25. And then one donate. I found 25 or 26.
25.
25? No, I think that it's 26 because okay, if everyone of the students, if every student donate one book, we will get 30. So we need to they donate 10, 10 more books. Okay. So we can and every class uh, students from different classes brought different numbers of books. So we need one student. If one student have one more book, uh, he will he will donate two books. Another student can donate two more books. Another student can donate three more books, three more than the one that we already count here. Tres más de los que ya habíamos contado aquí. ¿Sí? And if one of them donate four more books, we will have that those students donate more than one book. And here we have only four. So there must be 26 students that donate one book. Do you understand the idea?
No.
¿No? Ok. Es que, fíjate, si fueran 25, if the answer, you say that the answer is 25. Let's try. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 4, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Here we have 25 students. Okay. And if this bring two books, here we have already 25. Okay. If one student bring two books, another student bring 3, 4, 5, 6, and we add this, we will get 20. So we will have 45, 45 books. Do you understand this?
What are their consecutive numbers? 2, 3, 4, 5, 6.
Why consecutive numbers?
Yes.
Okay, it's because every student has can donate a book. Every student, okay, students from different classes brought different numbers of books. If, for example, here we already have 45. I don't know if the numbers are consecutive, but if we can construct one solution that use consecutive numbers, then we already have solved the problem. Si podemos encontrar, no sé si son números consecutivos, pero si los podemos encontrar, una solución con esto, sabemos que esa es la solución, ¿no? ¿Tú cómo le estás pensando? Give me your idea. Okay, you understand that if we make this, we will have 44, 45 books. Yeah?
Yes.
In this case, we have 45 books and 30 students. But if we use a number greater than 6, for example, we will have, now we have 46 books. We need that, we need to use less than, than 45. So I need to use numbers smaller than this. Tú dices que son 26, tú dices que son 25 estudiantes, ¿no?
Sí.
Para un libro. Pero si lo mínimo que puedo obtener, si son 25 estudiantes de un libro, es 45. We cannot use, for example, 2, 2, 2, 2, 2. Here we will have 25 plus 10, 35. Okay. But we want 40 books.
Each can give 3 books.
Okay. 3 books. Okay. This is your idea. Okay. But let's see. Students from the same class broke the same number of books. Students from different classes broke different numbers of books. And here it says that there's a student from 5 classes. If we use this solution, yes, this solution gives 40 books and 30 students. But then we have only students from 2 different classes. The class that broke 1 book and the class that broke 3 books. And we need that to have students from five classes. Do you understand this idea?
In your solution with 26 children that gave 1 book, the 26 children are in more than 1 class.
Yes, because we need students from 5 classes. All those students are in the same class. Only 1 student from the second class. Only 1 student from the third class. 4 students from the fourth class and 5 for the next class. We have students from 5 different classes here. ¿Sí entiendes la idea, Sebastián?
Sí.
El problema nos dice que debemos tener estudiantes de 5 clases diferentes. Todos los que trajeron uno son de la misma clase. Every student that bring 1 book, all the students are from the same class. This is from a different class. This is from another class. This is from another class. This is from another class. And here we will have 40 books. We have 30 students. And they came from 5 different classes. Yes?
Yes.
Your idea was a good idea, but we have only students from 2 different classes. Okay? ¿Sí queda clara la idea, Sebastián?
Sí.
Okay. Sí. Problem number 3. Okay.
Why is there an underline of the product?
Okay. It's not an underline. It's an upper line will be the from for this.
Sure.
Okay. When we write in algebra, when we use algebra, for example, we will have if we write AB in algebra, this means A times B. Si escribimos esto en álgebra, significa una multiplicación, ¿sí? But sometimes, in some problems, we need to use numbers from, we need to use 2-digit numbers. So, usually we will write this. This means that this is a 2-digit number. This is very useful if we want to write some idea. This is a 2-digit number. But every time that we want to use algebra with this kind of with this kind of in this kind of problems, we need to translate this to 10 times A because this is in the it's the 10th digit plus B because this is the unit digit. ¿Sí? Cuando nosotros queremos indicar, por ejemplo, un número de 2 dígitos, esto lo escribimos porque nos permite dar ideas muy rápido, pero tenemos que transformarlo en álgebra de esta manera. For example, if we have 74, we understand that this is 10 times 7 plus 4. We don't need, ni siquiera necesitamos pensar en esto. We don't need to think in this because we already have know how to work with this kind of writing. This is the kind of this is the way in which we write the numbers. But when we are solving problems, sometimes we need to write this and then we are going to translate this. For example, here we have 1, 2, 3, 4, 5, a 6-digit number. A, it's a digit that it's repeated in this place, this place, and this place. B, it's another digit and it's repeated in this place, this place, this place. ¿Sí? ¿Sí entiendes la idea, Sebastián?
Sí.
Okay. So this will not, for example, if we have this A, B, C, how we are going to write this in order to can use algebra?
100A plus 10B plus C.
Okay, that's right. So here it says that we are going to multiply 5 consecutive numbers. Okay. We are going to work to explore a little. If we multiply 5 consecutive numbers, 1 times 2 times 3 times 4 times 5, what will we get?
125 factorial.
Okay. If we multiply 2 times 3, 4, 5 times 6,
720. 6
okay.
factorial.
If we have 5 consecutive numbers, one of them is a multiple of, one of them it's a multiple of 10, ¿sí? Si tenemos 5 números consecutivos, forzosamente uno de ellos es múltiplo de, no, not of 10, of 5. One of them it's a multiple of 5. Okay? Do you understand this idea?
So there will always be a factor of 5. Well, the number will always have a factor of 10 because there will always be a number divisible by 5 and a number divisible by 2.
Yes, that's right. So we already know that B it's a 0. So the number that we want is this. A 0. A 0. A.
It says where A and B are non-zero digits.
Oh no. So it's okay. 5 consecutive positive integers is 120 times greater than AB, AB, AB. Ah, okay. Okay, let's see. You're right. You're right. It cannot be 0. We will have, we are going to multiply x plus 1, x minus 1. This will be 120 times A, B, B. Let me see. Let me see. Okay, yes, this is a multiple of 5. Um, wait, we can write this in this way. Okay. Do you agree that if we have this number, we can write this number like 1,100 AB plus AB?
Okay.
Okay. So this is a multiple of 101 AB. This is a two-digit number. And if we have this number, we will have AB times 101010. Do you understand this idea?
Okay.
Okay. Let's try something. And we want consecutive numbers, 5 consecutive numbers. This is a multiple of 10. This will be a multiple of 3. Do you understand what we are making? What
Um,
we are
um,
factoring, we are factoring the number.
yeah.
Okay. Let's try to factor this so we can see. What do we get if we factor this number?
We get,
This will be 100 times 10.
uh, multiplied by 3.
Yes, I lost a 3 here. Okay. Uh, okay. 10 times 3. And 3, 6, 7 divided by 2, 3, 4, 5, 7, no, 11, no. Okay, I don't know how to factor 367. It's a prime number? maybe it can be divided by 13. Oh, no, 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 no. AB. Ah, we have here an error. We have here a mistake. We make here a mistake. This is this because if we multiply, this is 2, 3, 4 plus 2 plus 1. Yes, this is the right. The right. We have a zero. Un cero que no era necesario. A zero that was not necessary. Okay. So we're going to. Okay. Let's divide this by 3. Then 1 divided by 3. 3. We have 1 here. Okay. Total mistake. We have 120 times AB times 3 times 3, 3, 6, 7. Okay. We need to factor this. Let's factor 3, 3, 6, 7. This is the problem. You already have find some factor of this number?
No.
Okay. We need to try. It's not divided, cannot be divided by 2. Neither by 3. By 5. Okay, let's try with 7. 3, 3, 6, 7 divided by 7. 856. 7.7. We'll have 7 and 4, 8, 1. Okay. Now we need to factor 481. Do you know how to find if a number it's a prime number?
Okay.
What what do we need to do?
Um, so we need to check if it is divisible by an any time below the square root of that number.
Okay. So we only need to try with prime numbers less than 25 because 20 by 20 it's 400. 25 it's 25 squared it's 625. So this this is not no es inmediato, pero tampoco es tan difícil. So try 2, no. 3, no. 4, 5, no. 7, no. Because 490 can be divided by 7. 483 will be divided by 7. Okay. After 7 comes 11. This number can be divided by 11.
No.
Okay. By 13. Four hundred and 81 divided by 13. 3, 3, 9, 21, 7. Okay. 13 and 37. Because 37 is a prime number.
No.
Okay. So let's see. So we want that 5 consecutive numbers uh, gives those 5 numbers gives a product that it's equal to 120 plus times AB, sorry, times 3 times 7 times 13 times 37. Okay?
So so we know it one of the numbers in x minus 2x minus 1x, x plus 1, x plus 2 is divisible by 7 and 13 and 37.
Yes. Yes, that's right. But I was thinking that maybe because 37 is a prime number, we can see if we can construct, we have those numbers. 120, it's 2 times 3 times 4 times 5. 5 por 4, 20, por 3, 60. Okay, yes, we have this. So, and we, this is a prime number. So one of the numbers must be a multiple of 37. Now, so if This is 37. Every one of the other numbers must be okay, must be two-digit numbers. For example,
Okay.
if this is 37, I'm still working with the solution. If this is 37, we need to construct 36, 34, 3, 35, 34, 34, and 33. Okay.
Mhm.
34, it's 17 by something, by 2. We can make a
Um,
35.
is there a number divisible by 13? 33 is not
Okay. Uh,
30.
okay, a number uh, near to 37, that it's a multiple of 13. Okay, that's right. That's a very good idea. We need a 39. If we take those two, we will have 37, 39. We need the 37. So we need to construct 38. 38. So we need 19 divided AB to construct a 38. We can construct a 35 here. We need to construct a 36. We can use those two, so we will have 12. We can get this 12 by 3 in order to that we can get a 36. We don't have another 3 there because we already used 37, 39, 35. Okay. And we can have here a 2. We already have here a 2. We need a 19 because 3x is 2 times 19. We need a 19. We need a 2 and we need a 3. Do you understand this idea? So the number that we need, it's 19 times 6. Oh no, we need a 114. Okay.
Why?
Okay, let's see. Again, we need a 37, okay?
Okay.
And you already said 37, we have the 37 here. And you say that we need a multiple of 13. We cannot have 13 because it's very far from the 37, okay? We cannot have a 26 because we need a 27, a 28, 29, 30, 31, 32, more than 5 numbers in order to that we can reach the 37, ¿sí? No podemos tener ni un 13 ni un 26. Entonces, puede ser un 39, debe ser un 39, ¿sí? El siguiente múltiplo de 13 sería 52 y ya está muy lejos del 37. ¿Sí? ¿Sí entiendes esa idea? ¿Por qué el 37 y el 39?
Sí.
Ok.
Um,
We,
39 also has a factor of 3.
yes, we can get this. We can take this 13 and this 3. Any 3. Yes. So we will need a 38. 38 is 2 times 19. We can take this 2. We already have a 2. And we still need a 19. So this 19 must be inside of this number. This number must be a multiple of 19. ¿Sí? ¿Ya entendiste esa idea, Sebastián? Para construir el 38
Um,
necesitamos 2 por 19. Aquí ya tenemos un 2, pero no tenemos ningún 19. This is not a 19, 19, 19, 19. So the 19 must be inside of the numbers. Uh, AB must be 19 times something. We still don't know the number. ¿Sí entiendes esa idea? Necesitamos que AB sea múltiplo de 19 para poder construir el 38. Ok. We cannot have a 14 here because in order to get a 14, we need 5 times 8. We have a 5 that we can use here, but we cannot use, we don't have an 8. So this number must be a multiple of 19 times 8. But this gives a 3-digit number. No podemos llegar al 40 porque para 40 nosotros necesitamos que exista 5 por 8. No, wait. 5 por 4 es 20. Ok, maybe, ok. 41. Okay, maybe we can have here 38, 37, 36, 35. We need, our solution must be, those can be the 5 numbers, or those can be the 5 numbers. Do you understand why?
yeah.
Ok, entonces hay que ver si podemos formar el 40. If we want here, let's try first this case. 35. 35, it's 7 times 5. We can construct a 35. There is 6. This must be 4 por 9.
Ah,
3
um,
times 12.
that's 4 times 3. That's 4 times 3 times 2. No.
Which one?
36 is 4 times 3 times 3.
4 times 9?
Yes.
Okay. We have here a 4. We have here a 3. We still need a number 3. Yes? This is the answer. AB must be 3 times 19. So 57. So we can use here the factor 3, and we can so we can get 36, and we need here and we can use here the factor 19.
Okay.
Yes? Do you understand the idea?
Sí.
And so let's get back to the question. What is the largest of those five numbers? 39.
Yes.
Okay. Well, I this is I don't know, but I like those kind of problems. First, we don't know what we are going to do, so we need to explore a little, and we need to transform the problem. I think that it's a beautiful problem. I don't know if you like those kind of problems. Sí,
I think I
¿entendiste
would.
el procedimiento?
Sí.
Ok, tuvimos que construir. Una buena práctica es que tú trates de reescribir los procesos después de cómo se resolvió un problema. ¿Sí? Yo creo que por hoy terminamos. Son las 4. Están estos problemas para irlos intentando. Entonces, vamos a ver qué teoría tenemos para resolver estos problemas y después practicamos, y después vemos, bueno, para ir construyendo la teoría faltante, ¿sí? Esto era una descomposición en primos. Entonces, pues por hoy terminamos. Que tengas una bonita tarde, Sebastián.
Bye.
Hasta luego. Bye. Is the square of an integral. How many integers from 1 to 3? If it's squared, how to do this out if it's squares. Okay. Okay. Getting it. Getting it. Getting it. Two numbers. One, two. Square number. Okay. ¿Dónde estás?